Assalamualaikum and good afternoon to all examiner. I am Nur Fadhilah binti Mohamad Noor, final year student of degree of Bachelor of Technology. I am presenting a proposal presentation on final year project entitled Study on Roselle Tablet Properties Developed from Freeze-Dried Roselle Powder under supervision of Dr. Nur binti Yusuf. This presentation is comprising of background and significances of study, problem statements, objectives, literature review, methodology, expected outcomes, and Gantt chart. Background of study. Roselle plant Hibiscus subdarifalum is belonging to the Malvaceae family. Cultivation of roselles is consisted of three types, which are green, red, and dark red. First and foremost, the concern is upon the development of product via optimization of ascorbic acid content from roselle calyces through processing into powder. Processing of roselle is due to the average moisture content of fresh calyces of roselle revolve around 86.06 plus minus 0.65% of a weight basis. Currently, beverages industry evolves around ready-to-drink RTD concept through the development of effervescent roselle tablet of encapsulated freeze-dried powder. The purpose of RTD is to provide convenience, prolong shelf life, and preserve palpable amount of ascorbic acids. Calyces of roselle need further processing steps in order of preserving the shelf life of the calyces. Ascorbic acid is the bioactive ingredients which is in high temperature, it becomes susceptible to degradation process. Significances of study. The significances of study are to develop new innovation of effervescent tablets and provide RTD products of driven convenience. Optimization of target compound for the development of this tablet is being considered to ensure optimum nutritional values of roselle being delivered to customers. The selection of effervescent tablet is due to its characteristics upon disintegrating prior to consumption. Let's move on to problem statements. Problem statements in this study is regarding the solid waste of common roselle tea drink. Previously, dried calyces of roselle are immersed in water as beverages and excess calyces remain unoptimized. Besides, the optimization of ascorbic acid during drying process into powder. Consideration on the susceptibility of bioactive compounds of vitamin C is upon any possibility of exposure to huge temperature difference. Moreover, problem arose in mint of powder is due to its hygroscopicity, which led to a need of proper storage handling of powder prior to consumption. Thus, further development of roselle powder into tableting may benefit the problem of roselle powder hygroscopicity. The objectives of this study are to determine the effect of different freeze-drying conditions upon presence of encapsulation materials on physicochemical properties of roselle powder. Next, to develop effervescent roselle tablets from the best roselle powder properties of different freeze-drying conditions. The third one is to determine the effect of different formulations of effervescent roselle tablet on the sensory characteristics. In this section, it is an overview on literature review by far. Roselle, which is classified as an annual plant that requires around 6 months in completing its production cycle. Hibiscus subdarifa wa artissima and Hibiscus subdarifa wa subdarifa are two botanical types of roselle recognized. Next, freeze-drying technique. Freeze-drying is a process of dehydration on frozen foods under vacuum condition. This process is involving sublimation phases to change moisture content in food products into gaseous form without the intermediate liquid state phase. Thus, its benefits are shape and color retention, better rehydration capacity, and suitable for heat-labile components. Next, the encapsulation materials that provide protection against degradation of bioactive compounds and ensure the control of compound release during disintegration of effervescent tablet. According to United States Food and Drug Administration US FDA, effervescent tablet is defined as tablet intended to be dissolved or dispersed in water before administration. Continuing with our next graphic is the study flowchart of this entire study. The study started from the selection of sample and sample preparation of roselle plant, freeze-drying of Roselle with coating materials, analysis of freeze-dried encapsulated Roselle powder, development of Roselle effervescent tablet from the best powder properties, analysis of effervescent Roselle tablets, sensory evaluation, and ended with data analysis and report. Materials to be used in this study are Roselle, hibiscus sabdarifalin, potassium citrate monohydrate, sodium bicarbonate, citric acid monohydrate, tartaric acid, PEG 6000, sodium benzoate, mannitol, sorbitol, aspartame, maltodextrin with 16.5 to 19.0 dextrose equivalent DE with different concentration of 10, 15 and 20% of weight over volume. Moving on to the next section, let's take a look at the methodology for development of Roselle tablet from freeze-dried Roselle powder. In the first place, freeze-dried Roselle powder will be prepared. Sample preparation consists of mixing of Roselle puree with different concentration of maltodextrin 16.5 to 19.0 dextrose equivalent. The concentrations are 10%, 15% and 20%, which will be described as different freeze-drying conditions in this study. Further step is freeze-drying of sample with the thickness of 0.5 cm spread on aluminium plates. Shelf temperature of freeze dryer is among -40 to +20 degrees C. Entire process of freeze drying will be estimated for 48 hours. As result from different condition of freeze drying, the yield will be 3 different Roselle powders. These powders will be analyzed for color analysis, water activity, moisture content, particle size, bulk density, tap density, and flowability. Data from this analysis will facilitate the decision on best Roselle powder properties for development of effervescent Roselle tablet. Consequently, the best freeze-dried Roselle powder will be formulated into effervescent tablets. And prior to developing the formulation, determination of ascorbic acid content of powder via titrimetric method will be conducted. The purpose of this method is to achieve similar ascorbic acid content for all developed tablets. Relationship stated will be used. The next step will be the development of formulated effervescent tablet via direct tablet compression method with cylindrical uniaxial compaction die. Diameter of tablet will be 20 millimeters and there are 6 different formulations of tablets to be developed. Compressed tablet will then undergo the analysis on effervescent tablet. The analysis will be comprised of hardness of tablet, dissolution time, effervescent solution pH, and carbon dioxide content. Among 6 different formulations of effervescent tablets that will be developed, there must be one tablet to be chosen as the most preferable products. Therefore, sensory evaluation process will be conducted via 100-point method on visual perceptions, olfactory sensation, taste and mouthfeel sensation. Simple random sampling will be applied on samples that will be dissolved with water and stored in room temperature for 30 sensory panels. Lastly, statistical analysis in this study will be one-way analysis of various ANOVA with significance difference of less than 0.05. Results will be presented as mean plus minus standard deviation. Continuing with expected outcomes for overall study. Physicochemical properties of Roselle powder will be expected to have less redness than fresh calyces, low water activity and moisture content, low particle size distribution, low bulk and tap density that lead to good flowability. Based on these physicochemical properties of powder encapsulated with 20% maltodextrin will be expected to become the best powder. As for effervescent Roselle tablet, the best formulation will be the formulation of F6. Continuing with our next graphic is the expected outcome for sensory evaluation. All data from 30 sensory panels will be expected to be simplified into this dummy table. This is the Gantt chart for the entire study. That is all from me. Thank you.